So hello everyone, today we are going to learn some basic information about heat treatment processes and their types. So let's get started. So as we all know, heat treatment is a very important process. Heat treatment is a very broad term and includes some heating and cooling operation in a sequence. Heat treatment process plays very important role while changing physical, chemical and mechanical properties of the material. Basically, heat treatment is consist of heating material at certain temperature, holding at that certain temperature for a certain time and cooling at a room temperature or below the room temperature. So now what are the advantages of heat treatment processes? We use heat treatment to increase hardness, abrasion resistance and cutting ability of material, to alter the physical, mechanical and chemical properties of material, to resoften the material after heat treatment or cooling operation, to reduce stresses generated inside the material, to stabilize the dimensions of material, to increase electrical and magnetic properties of material, to improve ductility and toughness of the material. Basically, there are four types of heat treatment process. Number one, annealing. Number two, normalizing. Number three, hardening. And number four, tempering. Annealing. Annealing is the process of heating a metal which is in a metastable structural state to a temperature which will remove instability or distortion, and cooling at usually slow speed so that room temperature structure is stable and stress free. Purpose of annealing: to induce completely stable structure, refining the structure, to reduce hardness, to reduce internal stress, to improve machinability, to improve mechanical, physical and chemical properties of the material. So now classifications of annealing: full annealing or conventional annealing, bright annealing, box annealing, isothermal annealing, spheroidized annealing and subcritical annealing. Normalizing. Normalizing involves heating a material to an elevated temperature and then allowing it to cool back to room temperature by exposing it to a room temperature air after it is heated. This heating and slow cooling alters the microstructure of a metal, which in turn reduces its hardness and increases ductility. Purpose of normalizing. Normalizing takes less time. It is more conventional and economical. It gives slightly more hardness and toughness. Hardening. Hardening is the heat treatment of steel which increases its hardness by quenching and tempering. Hardening can be as the process of heating a steel above the critical temperature, holding it at this temperature for considerable time and cooling suddenly. Purpose of hardening: to harden the steel to maximum level by austenite to martenite transformation. The main purpose of hardening is to increase hardness of the material and strength of the material. And we use hardening to increase wear resistance and cutting ability of the material. Tempering. Tempering may be defined as a process of heating steel below its lower critical temperature, holding it at this temperature for 3 to 4 minutes for each mm of thickness or diameter, cooling it either rapidly or slowly, except in case of steel susceptible for temper brittleness. Exact temperature at which tempering should be carried out depends upon the purpose of which workpiece is used. Purpose of tempering: to impact toughness to already hardened steel, to improve yield point of structural steel which is already hardened, to improve ductility. Thanks for watching.